Okay, so we're going to talk about the basics of a nephron. And I do have a video on the urinary system in great detail that's going to go into all the aspects of the nephron. So you're certainly welcome to go there if you need more detail. But this is going to be just our basic overview of the nephron. And then we're going to focus in on the renal corpuscle and see the details of how it works. So first, let's take a look at this generalized nephron. So this is just a kind of a big picture view of the main components of the nephron. And the nephron itself, just as a refresher, is a microscopic tubular structure. And we're going to have about 1.25 million of them per kidney. And these are found primarily in the renal cortex, which we just went over in the basics of the kidney video. So in the renal cortex are these microscopic tubular structures called nephrons, and their job is to filter the blood and create what we call urine. So looking at the two big areas of the nephron, we have first the renal corpuscle. And the renal corpuscle is just this area right here that reminds me a little bit of a fishbowl kind of tipped over on its side. So we have the renal corpuscle here, and then from here to here, we have what's called the renal tubule. And so this is a tube-like structure, and its job is going to be to sort of tweak the filtrate to create the urine that we're going to end up with at the end of this process. So the renal corpuscle, let's go back and see what its components are. So we've got the glomerulus, which is really best defined as a knot of capillaries. So it's a knot of capillaries known as the glomerulus. And then the fishbowl around it is known as the Bowman's capsule. So together they are the renal corpuscle. Then we move over to the renal tubule. The renal tubule is made up of three things. We have the proximal convoluted tubule, or PCT. We have the loop of Henle, which has a descending going down and an ascending limb going up. And then we've got the distal convoluted tubule, also known as the DCT. So those three items make up the renal tubule. From the renal tubule, we then head over to the collecting duct. And the collecting duct is really the last stop on our way out towards draining from the kidney and moving on down the ureter to the bladder. So collecting duct, and we're going to drain out of the nephron. So when urine is made, keep in mind the whole idea is we're filtering the blood volume. As we go through everyday life, we build up toxins and waste in our blood from our metabolism. And those things need to be removed from the blood. So think of the kidneys as your blood's filtration system. How do we filter the blood, keep all the good stuff in the blood, but just get rid of the yucky stuff? Well, it's all going to begin here in the renal corpuscle. So for the rest of the video, I would like to focus in on just the renal corpuscle to see where all of this starts. Okay, so in this next image we're going to look at, we are focusing solely on the renal corpuscle. So what you can see behind me here, this is actually a zoomed in view of just the renal corpuscle. So I took that fishbowl that was on its side we talked about, and the knot of capillaries, the glomerulus, and then just kind of blew that up and put it right here. So looking at the renal corpuscle up close, we can see our little fishbowl, our Bowman's capsule here and here. And then inside the Bowman's capsule, we have the glomerulus. And the glomerulus, remember, is our knot of capillaries. There is an afferent arteriole, afferent meaning going in, and an efferent arteriole meaning going out. Okay, so blood's going to come in and go through the glomerulus and leave here. Now I want you to focus in a little bit more at the glomerulus because there's something special on it that's kind of awesome. So on the capillary bed are these weird little cells called podocytes. And these are cells that have little feet that wrap around the glomerulus. And the little feet, as one is pointed at here, are called pedicels. And kind of think of those little feet as sort of interlocking a bit like this. So we've got some gaps between my fingers, which represent filtration slits. So in between these little feet are what we call filtration slits. So the filtration slits are where we will be able to kind of squeeze out a plasma-like solution from the blood, but avoid putting into that plasma-like solution things like red blood cells. So kind of think of it a bit like filter paper or a strainer for the blood. So the blood can come in and we can squeeze out plasma solution from the blood into this Bowman's capsule, and that is what we call filtrate. Now that filtrate is not going to have blood cells in it, because I think we would probably be concerned if there was a lot of blood in our urine. It's not going to have a lot of blood cells in it because that filter paper is going to allow us to filter out just the plasma-like solution. And that plasma solution or filtrate is what will head into the renal tubule to be converted into urine. So we don't call it urine yet. It's got a lot of tweaking that it needs to undergo before we call it that. So if we zoom in just a little bit closer to these podocytes, what you can see up here is this is a cross section through a glomerular capillary. There is our red blood cell, and then of course around it would be plasma. And going back to our basics of blood, blood is made up of formed elements like platelets, red blood cells, and white blood cells, and they're suspended in plasma. And plasma is kind of a straw, clear colored fluid that the blood cells float around in. And so the plasma's around here and the red blood cells here. And then we've got our big podocyte that's blown up. And here are the little podocyte's feet. And in between those little feet, we have filtration slits, which are just big enough for the plasma to squeeze through under blood pressure and fill that Bowman's capsule. And in that plasma will be the dissolved toxins and wastes and things that we do want to get rid of in the urine, but we're keeping those red blood cells and large proteins in the blood system where it belongs. So that is how a renal corpuscle is going to work, using blood pressure to filter blood through those filtration slits. Then our plasma-like solution or filtrate will enter the renal tubule, and then from that point on, we will tweak it to convert it into urine. So let's look at this in an everyday example. Okay, so here I have a great model of what blood really would look like if we could shrink ourselves down or blow it up really, really big. So this is our blood vessel, and you can see it's opened up so that we can see the details inside. And as we mentioned previously, blood is a type of fluid connective tissue. So it is going to be made up of formed elements, which represent our cells. So our red blood cells, white blood cells, and platelets. And you can see all those guys in there. And then this clearish, little bit of a yellow tint fluid all around these cells, that is our plasma. And the plasma is where our toxins and wastes are going to build up. So remember, we want to be able to use the kidneys and the nephron to leave these cells in the blood, but we want to filter this plasma out and get all those dissolved wastes and toxins out of it. So that's where your renal corpuscle comes in. So the renal corpuscle, remember, is made up of the Bowman's capsule and glomerulus, and it is covered with those special cells called podocytes. And remember that in between the podocyte feet, we have the little filtration slits. So we can squeeze the plasma through and leave the red blood cells in the blood system. So I have a little visual aid to show you so that you can see what I mean by this in an everyday relatable example. And I know you guys are gonna think I have way too much time on my hands, and you're probably right. But this is our blood representation. And what it is literally water and pasta. And the pasta is dyed red for your viewing pleasure. It looks like red blood cells. Wrong shape, but you get the idea. So we've got our blood representation here. So remember that the water is going to represent the plasma, and then these guys will represent our red blood cells, okay? So when we go into the renal corpuscle, we are expecting those podocytes to act as a filtration system. So that's why we have our trusty colander, strainer, whatever you want to call it. This represents the podocytes that are around the glomerulus. So the idea is if we dump this blood into our Bowman's capsule glomerular combo, our renal corpuscle, what should come through the little holes or the filtration slits would be the water from our pasta, the water, which represents plasma, and what should stay in our strainer or colander should be our pasta or red blood cells, okay? So I'm pretty sure you get where I'm going with this, but I'm going to now simulate this process, which we've all done a million times. And now you can see that the blood cells have remained in the blood system. Those little filtration slits were too small for those red blood cells to squeeze through. And so all that we have now in this bowl is just our plasma, which is our pasta water. So plasma that contains dissolved waste and breakdown of products of metabolism. And this is what we call filtrate that will continue on to the rest of the nephron for tweaking. And at the end of that, we will have urine.